He knows it's the
Told. Right. Question 6. The first three terms of an arithmetic progression are given like that. Find the value of x. As soon as it says it's an arithmetic progression, that means the difference between each successive term is the same. So what we're going to do with that is, if this is an arithmetic progression, the difference between the second and the first term, so as it's an AP, the difference between the second and the first term must be the same as between the third and the second. So that's it. That's all we need to do. Set up an equation that looks like that. That's x plus 4 take 2x. The difference between the second and first terms must be the same as the difference between the third and second terms. So again, we've now got an equation in terms of x. It's just one unknown in there, so we should be able to solve this for x. What have we got? X, take away the 2x, so we've got 4 minus x there. We've got 2x, take away x there, so we've got an x there as well. And minus 7 minus another 4, so take away 11. If we rearrange this, add the 11 to both sides, add the x to both sides, so x is 15 over 2, or 7.5. And we get that from that. And now, when you see that there, it is so simple, isn't it? Part 2. So if we've used that principle there, then this must be about the same kind of principle. Part 2, the first three terms of another sequence are also that, but this one, in part A, verified that when x equals 8, the terms form a geometric progression. Find the sum to infinity in this case. Okay. This just says verify. We could go about this in terms of finding the value of x when it's a geometric progression, but this says check that it is. So our first step is going to be, we're going to sub in some values there and see what that means the sequence is. If x equals 8, then the sequence is 2x would be twice 8, so 16. The next term would be x plus 4. That's 8 plus 4, so that's 12. And the next term would be 2x minus 7, so that's 16, take away 7 is going to be 9. So that's our sequence. Okay. We've got to verify that in that case this is a geometric progression. So if it's a GP, it has a common ratio. And so we've got to check that the common ratio is the same for both of these terms. So R is what you get if you divide. Instead of subtracting, we're going to divide this time. So 12 divided by 16, which is 3/4. And R is 9 divided by 12, which is also 3/4. And because we've got the same common ratio between those two as we did between the first two, we've shown that it is a GP. We actually have to do that thing where we check, we make a convincing argument that it's a GP. What they were looking for here is some kind of convincing explanation. They needed to have two values of 0.75, two values of 3/4 to be a convincing argument. Okay? I actually wanted to be extra careful with this, so I wrote the sequence as being 16, and then 16 times 3/4, and then 16 times 3/4 squared, just to show that we get the same thing. The question then did say, well, hang on, that was 4 marks.
You had to find the sum to
infinity. It then said find the sum to infinity in this case. Yeah, it did also say find the sum to infinity. So So we've got A is 16, R is 3/4, and the sum to infinity would be A over 1 minus R. So we've got 16 divided by 1 minus 3/4 is a quarter. So we get 64. The 4 marks there, not many of you got 4 marks. Lots of people got 3 marks because they found the common ratio and they used it to find the sum to infinity. But there wasn't a convincing answer, you didn't actually show that the common ratio meant that the whole thing was a GP. You needed to get 2 values of 3/4 out. Find the other possible value of x that also gives a geometric progression. Well, this is actually using the same idea as we've used in part 1. Part 1 said that to find the common difference, if you do the second term, take the first, it's equal to the third, take the second. Well, this one says that if we divide, that our common ratio is the second term, is that right? Yeah, divided by the first one. And that's the same as u3 divided by u2. So we can use that idea and say if we do the second term was x plus 4 divided by the first term, which is 2x. That must be equal to the third term, 2x minus 7, divided by the second term, which is x plus 4. And that, I think, is an important equation to set up to help us on our way with this. We're going to do some multiplying through to get everything onto one line. So if we multiply both sides by x plus 4, we get x plus 4 squared. Multiply both sides by 2x. And you can see we're heading towards a quadratic. I'm going to multiply this out. I think we get that. 4x squared minus 14x on the other side. So collect everything together on one side. 0 is 4x, 3x squared, so we'll take away one of the x squareds. We've got minus 14, we're taking away another 8, so that's minus 22x. And we've got a negative 16 there. Now we need to factorise this. But hang on, it's nowhere near as bad as it seems, because we know that one of the solutions is x equals 8, because that's what the question already told us. So one of the brackets has to be x minus 8. If it isn't, then we've done something wrong to get to this part, because the question had told us that a common ratio of x equals 8 fitted. So if x minus 8 is one of the brackets, we must have a 3x at the start there to make the 3x squared. To get minus 16, we have minus 8 times, that has to be plus 2. So that must be the other bracket. Just a quick check, does that work? Well, that would give us minus 24x plus 2x is minus 22x. Right?
You do like factor theorem?
You could have done the factor theorem, or it's just a quadratic equation, so you could have stuck it in a quadratic formula, I guess. Come up with the value if you couldn't think of another way to do it. So we've got, as our solutions to that, x equals 8 and x equals minus 2 over 3. The question said find the other value of x. So x equals minus 2 over 3 also gives a GP. That's the value that we need to identify at the end. Okay?
How did you find that second value of x again? Like, how did you know what the second bracket?
That's okay. It's a quadratic equation, so we can use the formula. We could have factorised it how we always factorise this, so you might have said 3 times minus 16 is negative 48. I think the two things the times to give that.
Okay.
24 and 2 would have worked out, wouldn't they?
Yeah.
Or, because the question had said x equals 8 is a solution, x minus 8 has to be one of the brackets. So having identified that, to get the 3x squared, you have to have a 3x at the start.
Yeah.
3x times x to get this 3x squared. To have a minus 16 there, we have to times minus 8 by plus 2. So it must have been 3x plus 2. That gives
Yes.
grand.